are the storms that we sampled, and the lines that are thin are the storms that we did not sample. And you can see here that we have Kyle and Josephine, thin lines, and we got almost 25% improvement, maybe a little bit more. Very large improvements. Those are some of the largest improvements, even though we never flew anywhere near those storms. And then, for example, Hurricane Hannah here, we got very little change on average for the lifetime of the storm, even though we flew a number of synoptic missions. So looking at some of the individual storms, in these plots on top here are the percentage improvement, and this is the actual absolute improvement. So improvements are on top, degradations are below. And so this is for Hurricane Gustav in the Atlantic. We got about 10 to 15% improvement, but there's great variability in whether the forecasts were improved or not. And these horizontal lines here are show when we actually flew missions anywhere in the globe. So here you can see we flew Gustav here. This was one flight, but the data got into 2 cycles. Another mission here, another here, and another here. So there were 4 missions. And in this case, you can see that we had some small improvements throughout this period when we were only flying in the West Pacific around TCS 025. But we were still improving the Gustav forecast. But once we started flying around Gustav, we got these very large improvements in the forecast. So this is sort of what we would expect to see, hopefully, that the extra data are improving the forecast globally, but when you actually do some targeting to improve specific forecasts, you're going to get larger forecast improvements. If we look at Hurricane Hannah, which is the case that I showed that we barely got any improvement at all, we don't necessarily see that as clearly. Hannah lived quite a long time, almost a week, before we actually flew it. There were only 2 missions here and here. And we did get large improvements, but we got some degradations through that period as well. But early on, we got some rather large degradations to the forecast. And I'm going to look at this case here, which was a case in which missions were flown around TCS 026 and Hurricane Gustav further to the west. And you can see that there was quite a large degradation to the forecast. In these plots, the green is the operational forecast with all the droplets on data, and the blue is the forecast with the droplets on data taken out. So we didn't get a very large change, and this tends to be what we see. We don't get a huge change in the forecast, but plotting it, but it could be a couple of 100 kilometers by 24 to 36 hours, as was the case here. And the actual track is shown here. It took a southward turn toward Haiti and meandered around there. And one thing that you can see here is this is the deep layer mean plot. You can't really see the geography here, unfortunately. But TCS 025 is in the western Pacific, and that's what was sampled. And Hurricane Gustav near the western tip of Cuba was sampled. Hannah was just a little bit further to the east, and Ike was well out in the eastern Atlantic. And there was a subtropical ridge up to the north. And what happened forecast after forecast during this early period before we sampled around Hannah was that this anomalous cyclonic circulation developed off the U.S. East Coast. And what that did is it pulled the forecasts further north. And where this came from, this wasn't in any of the initial conditions. It just happened whenever this trough moved off the U.S. East Coast. Suddenly, it got stronger in the all-drop case than in the no-drop case. And I'm not quite sure what caused that for about 2.5 days. And it'd be interesting to go back and look at that. But I'm not sure that, given the model runs, that we can actually tease out what was going on there. The other interesting thing was that we sampled Gustav, but you can see here that there was a very small impact here, about as large as this little feature here. We didn't sample around here, but we sampled here. And we, actually this is incorrect, we didn't sample here in this area, but there was a very large impact in the model. So where you're actually looking at where you're actually sampling isn't actually telling you where you're having the largest impact in the model. For Hurricane Ike, this was another interesting case that actually we had very large forecast improvements here before we flew any Ike emissions, and once the Ike emissions started here, we had some small improvements and then some degradation. So this is the opposite of what we would hope to see. And I'm going to look at two cases here. This is when we sampled Hurricane Gustav, and this is when we had gone 2 days without any sampling globally at all. And we had an improvement here and an improvement here. In the first case, we didn't sample anywhere within about 4,000 or 5,000 kilometers of Hurricane Ike, but look at the very huge forecast track impact that we got. With the operational model in green, we were relatively close to the best track, but with the taking the drop wind sondes out globally, nowhere near this area, the forecast tended to recur. And the reason for that is it looks like we had this Rossby wave train here of all these systems, and then Josephine was just off to the east there. And we had this very large impact in this cold low feature here that is not associated with any of the data that we actually assimilated into the model. And again, when we did sample Gustav here, we had a very small impact, but we had a very large impact here in the area near Hurricane Ike. And what this did is it caused an anticyclonic circulation here that kept Ike moving further to the west. And when we removed the data, it caused Ike to move to the north. So nowhere near where we put the data into the model, we're getting these very large impacts. And the next case here was a few days later. Gustav had made landfall and had already returned. Hannah was making landfall. Here's Ike, here's Josephine, and here's this very large subtropical ridge up here. And you can see that it was a much smaller impact, but again, the forecast of Ike was much closer to the best track than when we removed the data. And again, we have this, this is when we didn't have any data globally for 2 days, but we still had very large differences in the initial conditions throughout the basin. And you can see here that we had this circulation here that drove the no drop forecast a little bit further to the north. Tropical storm Josephine, we didn't drop any sondes anywhere near tropical storm Josephine. It was well out in the eastern Atlantic, but we got very large improvements in the